So, good morning. Before actually going in for the high voltage testing in the laboratory, it is very important to plan the laboratories to conduct the high voltage tests and also the laboratories which could be useful for the research activity and training aspects. So, proper planning of high voltage laboratories is essential before the equipment is being evaluated. So, we were discussing about the importance of the industrial and economical development which demands the use of more and more electrical energy. This electrical energy needs to be transmitted over long distances and in large quantities. So, in case of HVDC line, large amount of power could be transmitted. So, large amount of power needs, we know that extra high voltage and ultra high voltage transmission lines. So, in the country presently there are several 765 or 800 kV AC and few 800 kV DC lines which have recently been in operation, and also the transmission voltages of 1200 kV are in experimentation. So, this very fast development of power systems should be followed by the system studies on the equipment and the service conditions which they have to fulfill in the field. So, these conditions will also determine the values of the required test voltages. It could be of AC, a power frequency voltages of 50 hertz, or impulse of lightning which is 1.2 by 50 microseconds, or a switching impulse of 250 by 2500 microsecond, or an oscillatory type of impulse which is seen in the field, or it could be a DC voltages under specific conditions. So, the high voltage laboratories which are to be planned should be are essential requirement, particularly for making the acceptance tests for the equipment that go into operation, particularly in case of extra high voltage and ultra high voltage transmission systems. In addition, these high voltage labs are also used for the development work and research work on various equipments, and to plan to ensure that the economical and reliable equipment needs to be used in the EHV and UHV transmission systems. So, what are the test facilities which could be provided in the high voltage laboratories for the research, developmental and testing aspects? So, the high voltage laboratory is expected to carry out withstand, that is for a duration specified by the standards, for what time the equipment could withstand in case of the surges which it sees in the field conditions, and could be a flashover test. So, it could be a withstand test or a flashover test at appropriate high voltages, and these withstand or flashover tests could be conducted on the following transmission equipment like transformers. Again, transformers will be tested for AC withstand, impulse withstand, chopped wave and so on. Lightning arresters, again lightning arresters have to be tested for various type tests. It could be lightning impulses of 8 by 20, a switching impulse of 30 by 60 microseconds, a high current test of 4 by 10 microseconds, and a long duration test which ranges up to few milliseconds. So, apart from that, there is also the operating duty cycle tests which the lightning arrestor will undergo in the laboratory, where both the AC and the impulse currents are impinged on the surge arrestor or a lightning arrestor. So, apart from that, the tests on isolators and circuit breakers, it could be different types of insulators, ceramic, porcelain, glass or a polymer type of insulators, various types of cables, capacitors, tests on line hardware like the corona control rings, yoke plates, various types of accessories, could be of mid span compression joint, repair sleeve, vibration damper, so on and so forth. Apart from this, some other equipments like the reactors etc. are also to be tested in the laboratory. So, any high voltage lab is expected to carry out both withstand or a flashover test and certify these equipments for the use in the field. So, as mentioned earlier, various type or different tests are normally conducted on a HV or high voltage equipment include the power frequency at withstand test, wet, and it has to simulate the rain conditions and dry conditions. So, the equipment will be tested for the power frequency, withstand could be a 1 minute or a 5 minute time interval, wet test with rain and dry conditions. So, impulse test, again impulse test appropriate to the voltage of the equipment which is to be tested. Impulse test could be of lightning impulse of very short duration or a switching impulse of a higher duration, and sometimes it could be a oscillatory type of impulses which are required to test the laboratory, or a chopped type of impulse, either it could be on the front or on the tail. Then DC withstand test, again it specified voltages, specified time, could be of 1 minute or a 5 minute withstand DC test for cables, capacitors and so on. You have switching surge. Switching surge again is of for voltage applications it is 250 by 2500 microseconds. In case of lightning arresters it could be 30 by 60 microseconds. So, apart from these tests under polluted or contaminated environments have to be carried out on various type of high voltage equipments. Most of these equipments will be operating in the outdoor environment. So, the contamination or a polluted test is essential for the equipment. Apart from the polluted or a contaminated test, the partial discharge very important for the cables, transformers and other equipments which are to be performed in the lab. Then radio interference voltage measurements, this is a very important measurements which are carried out in the high voltage laboratory for various high voltage equipments. It could be for insulator strings, the line hardware, the conductor, the transformer or many equipments where this test is important, needs to be done at the laboratory. In addition, high current tests at power frequency and impulse current tests on transformers, line conductors and lightning arresters are equally necessary. So, apart from the above facilities which are normally needed for routine testing, the laboratories, that is the high voltage laboratories, are expected to have facilities for studying the dielectric properties, important, very important to study the electric properties of insulation and the insulating materials. So, very important. So, lab should be equipped with all the facilities and also should have to cater to the requirement of the studies on insulation and insulating materials. So, activities and studies which could be done in the high voltage laboratories, in addition to the tests which mentioned earlier on various equipments, the lab should cater for the research and developmental work which could be carried out on various equipments. This is very important. This could include determination of the safety factor particularly for dielectrics and reliability studies under different atmospheric conditions. This could be due to the effect of rain, fog, mist or the industrial pollution or contamination etc., at very high voltages than the test voltage required. So, sometimes the laboratory should be able to provide and it is required to study the problems which could be associated with the test lines and other equipments under natural atmospheric or pollution conditions which normally cannot be done indoors. So, very important. So, laboratory should be able to cater these requirements. So, coming down, what are the various types of classification of high voltage laboratories? So, depending upon the purpose and resources available, the laboratories can be classified broadly into 3 types. One is the small laboratories, the second being the medium sized laboratories, the third being the large laboratories or high voltage laboratories which could be used for testing and certification of the high voltage equipment. So, we will discuss one by one the importance of the laboratories and where these laboratories are useful. So, first we focus on the small laboratories. A small laboratory could be a one that could contain a DC or a power frequency AC equipment of less than 10 kilowatt or 10 kVA rating. And here in the small laboratories, impulse equipment could be of energy rating anywhere between 10 kilojoules or sometimes less. The voltage ratings of the equipment could be about 300 kV in case of a single transformer or a 500 or a 600 kV AC. So, any of these choices. For a cascade arrangement in case of 2 or 3 more units of transformer used, sometimes small laboratories could also have cascade units of plus minus 200 to 400 kV DC and less than 100 kV impulse voltages. This is the normal ratings of the equipment which are housed in a small room or a hall, a typical size being 15 meters by 10 meters by 8 meters. This could be a laboratory layout. So, sometimes the equipment ratings may be limited such that they can be accommodated in a smaller room than the size specified. It could be 5 meters by 6 meters or so. So, such laboratories what we call as small laboratories can be built with an investment of 2 to 10 million or slightly higher than this. Here the laboratories are meant for the engineering colleges, universities or some small industries use for their products evaluation. So, to build such a facility with small resources, particularly for conducting high voltage tests or research or important training. So, but in case of engineering colleges and universities, most of the labs do have a facility for lower level of AC voltage, a DC and a impulse. So, particularly to maintain or to impart the training of the undergraduate or the postgraduate students. So, this lab will be known as a small classified as a small laboratories. The second type of the laboratory with the high voltage equipment known as a medium sized laboratory or basically known as an industrial type of laboratories. Usually used the medium sized labs are normally used by the industries. So, here the medium size laboratory main function will be for conducting the routine tests. Routine tests are carried out on each and every component or each and every product of the which is manufactured in the industries. So, planning of these laboratories should include the transportation, ground transportation, the handling equipment like cranes or the rationalization of the test procedures by making instruments easily accessible and also providing room for possibility of increasing maximum voltage ratings and so on. So, such a laboratory may initially contain power frequency testing facility, that is AC facility, anywhere between 200 to 600 kilovolts. It could be proposed to be tested for cables or transformers etc., but its kVA rating will be much higher, could be anywhere between 100 to 1000 kVA. And in medium sized laboratories, the impulse voltage generator could be of 2 to 100 kilojoules or sometimes could be higher. So, other test equipments like the impulse current generator for testing of surge arresters or diverters, and DC test facilities for testing cables and capacitors can also be made available in such medium sized laboratories. So, normally in industrial laboratories not much emphasis is generally given for undertaking research work, and little flexibility may be available for incorporating new equipments. So, this is generally used for a routine type of testing on the products manufactured in a particular industry. The third is the large size laboratories, a very important laboratories. These laboratories are meant to carry out testing and undertake research and developmental work, and will contain almost all high voltage and high current test equipments and the facilities which are required for the certification of any equipments which are to be carried out. So, the large sized laboratories contain the basic facilities like the laboratories could have one or more high voltage test halls, huge halls. The facilities could be for the testing of corona and pollution test chambers, as separate chambers for testing the contamination of the equipment or the products like insulator string or any other equipment. There could be an outdoor test area for tests on large size equipment, on transmission line components, and very large area where the towers also could be tested. So, towers have to be tested in for the mechanical loading and so on. So, this type of laboratories could have a facility for both outdoor and indoor arrangements. The laboratories will have a controlled atmospheric test rooms and chambers for conducting experiments or testing or certification of components pertaining to this atmospheric condition tests. These laboratories in general will have a computing facilities, a conference halls, library with good office facilities, and a provision for overnight tests and also stay. So, these are very large laboratories, certification type laboratories. One example in the country could be the Central Power Research Institute, where they have the outdoor and also the indoor facilities, the testing aspects, and several of these are available. The size, the ratings of the test equipment will be quite large. The building and equipment include workshop, material handling equipment like cranes, ladders, air cushion, platforms, etc., and also large control and electric supply facilities could be up to few kVA or MVA rating. The personnel who are connected with such a large size laboratories normally include a director or a manager of the laboratories, few group leaders, section heads, test engineers, support staff, technicians. Again, technicians could be of a skilled or a semi skilled workmen, etc. And these people are available separately for the research as well as the testing, measurements to be made on electronic computer facilities, so on and so forth. So, large size laboratories will employ all these requirements where the products to be tested certified to the requirement of the national and international standards have to be followed. So, very important, and these labs are normally recognized by the national and international accreditation boards. So, typical size and rating of large high voltage laboratories, a few of the is shown here. The test voltage of equipment of AC is shown here. System nominal voltage, the voltage could be 400, 525, 765, 1100 and 1500 kV. So, the line to ground voltage is indicated here. For 400 it is 35, 525 it is 420, 1100 is 900 and for 1500 it is 1220 kV. So, the power frequency withstand for these components of a 400 kV has to withstand 530 kV. In case if it is 520 it has to withstand 760, so on. For 1500 kV it is 1920 is the requirement of power frequency withstand voltages. Again, withstand could be for a minute or 5 minutes. Again, this is dependent on the instructions or the standards procedures to be followed. So, impulse withstand, again impulse withstand for a 400 kV system, the impulse withstand level will be 1425 kilovolts, and in case of 1500 or 1100 kV it is 2800, and in case of 1500 it is 3500 kV. For switching surge, again lightning impulse withstand is 1.2 by 50 microseconds. For switching surge voltages it is 250 by 2500 microseconds, where for a 400 kV system the switching surge withstand level could be 875 kV, where the equipment should be able to withstand these surges for a specified number. It could be a 10 positive and a 10 negative applications, or a 5 positive and a 5 negative applications. These are normally specified in the standards and an agreement between the manufacturer and the utilities. So, similarly for 765 kV you have to see that the switching surge withstand voltage is 1350, and higher the voltage 1100 is 1800 kV and so on. For pollution or a contamination, very important, as the voltage level goes higher and higher, EHV and UHV contamination or a pollution is a very important criteria to be considered for the design applications. Here the voltage level for 400 kV you can see that the withstand for the pollution or a contamination is 280 kV. In case of 765 kV it is 500 kV, and in case of 1100 it is 700 kilovolts, and for 1500 it is 950. These are the various values for the power frequency, lightning impulse, switching impulse and pollution tests withstand voltages. So, for AC systems, in case of DC systems you can see the table which shows here test voltages for various equipments with the DC stress. This could be in case of plus minus 400 kV nominal operating voltages, the DC withstand voltage should be 800 kV, twice of the nominal operating voltage, and the reverse polarity test voltage for a 400 kV nominal system should be plus minus 600 kV. The impulse withstand voltage is 1350 kV, and the switching surge withstand voltage is 1000 kV, and the pollution test voltage is 440 kV. It is more higher in comparison to the AC 400 kV systems. It is almost twice the level which is required. So, similarly for plus minus 600 kV these are the values. 1200 is the withstand voltages, the reverse polarity voltage being plus minus 900 kilovolts, the lightning impulse is 1900 kilovolts, the switching surge withstand voltage is 1500, and pollution test voltage is 660 kV. And for 800 kV systems, HVDC systems, the DC withstand voltage is 1600 kilovolts, the reverse polarity test voltage being 1200 kV, the lightning impulse voltage is 2300 volts, the switching surge withstand voltage being 2000, and the contamination or a pollution test voltage being 880 kilovolts. So, very important, these are all as per the standards which have been specified both nationally and internationally. So, this gives the test voltages required for different system voltages for AC and DC. Again you see various power frequency for nominal operating voltage of 400 kV, the power frequency voltage requirement is 800 kV and pollution is 300, impulse standard is 2400, switching surge is 1150, and for 765 kV AC system you require the equipment to be tested for 1000 kV withstand power frequency withstand 50 hertz and a pollution for 500 kV and an impulse test voltage of 3 million or 3000 kV and 1750 being the switching surge voltage. So, these are some of the values which have been prescribed for both the AC and DC systems. Again DC 400 kV it is 800, for pollution it is 500 kV, impulse being 1750, 1300 kV, so on and so forth. So, the high voltage laboratories which we discussed could be of either indoor type or outdoor type. The indoor type facility, that is a high voltage which is of indoor type, has advantage of protection of test equipments against variable weather conditions, and the design will be simplicity in design and control of test equipments, and there will be a provision for observation of the facilities during the testing or during the experimentation which is being conducted. So, the outdoor facilities or outdoor laboratories have some advantages in case of like less cost. This could be due to the absence of building cost and the planned facility layout. So, but there are a few points to be noted here. The outdoor test areas have some limitations such as absence of lifting and supporting facilities, because it is an outdoor facility. Fixing of the crane and other equipments may be difficulty in the outdoor yard. The climatic conditions which may restrict or impede the testing, particularly when the experiments are to be conducted, the outdoor facility during the monsoon conditions or the rainy condition could be an impediment on the testing conditions. Also the reproducibility of results which are conducted outdoor not being guaranteed due to the uncontrolled atmospheric conditions because of the humidity, temperature, so on. The results may be difficult to reproduce. Next point being the artificial and wet tests which are difficult due to wind variation. So, the carrying out artificial pollution or a rain test facility, there is a wet test facilities on the equipment. In case of outdoor it will be a difficult task because of the wind direction and so on. So, it is recommended to carry these type of tests in a closed enclosure, in a closed volume, in an indoor environment where better options for the reproducibility and also easy in carrying out this experimentation is possible. So, when high voltage laboratories are planned as indoor laboratories, important is to see that the following are considered points which are to be considered. So, like the size of the test equipment, see in indoor the hall, the laboratory to be planned depending upon the size of the test equipment. This could be for AC, DC or impulse generators. The clearances, very important, the distances or the clearances between the test object and the ground during test conditions, and also between the high voltage terminals and the earth or a grounded surroundings. It could be a metallic structures nearby or a grounded surroundings like walls or roof of a buildings, or it could be of other test equipments which may not be energized. So, these points have to be considered when high voltage laboratories are being planned as indoor laboratories. The table gives the approximate dimensions for testing apparatus, any apparatus and test objects. So, here you can see the nominal system voltage for the equipment that is in kV RMS. For a 400 kV system, the AC test transformer height, this is in meters, it could be around 10 meters, and impulse generator, the height of the impulse generator in meters could be anywhere between 6 meters for a 400 kV system level. The test object dimensions, again the equipment to be tested could be anywhere between 7 meters in length, 2 meters in breadth, and 11 meters in height. So, this has to be kept in mind before designing the laboratories or planning for the high voltage laboratories. Similarly, for 765 kilovolts system, you require the minimum the dimensions for the AC test transformer height could be anywhere between 15 meters, that is around 45 feet. Similarly, for impulse generator it could be 8 meters, and the test object dimensions could be ranging from 11 meters in length, 2 meters in breadth, height could be 17 meters or so on. As the voltage level goes higher and higher, for 1100 kV the dimensions also change. So, it could be 18 in case of a transformer height which is required, 12 could be for the impulse generator, and 17, 2 and 24 could be the height, length, breadth and height for the test objects to be installed. So, these are all the approximate dimensions of the testing apparatus and the test objects which have been indicated. The approximate working clearances which are normally recommended for the laboratories are as follows, which are shown here. In case of AC, that is a 50 hertz power frequency voltages, approximately as a thumb rule it is taken as 200 kV RMS per meter, and for DC voltages it is taken as 275 kV per meter. For impulse it is 500 kV per meter, that is the clearances, working clearances or the distances, minimum distances to be maintained. For AC approximate 200 kV per meter, DC 275 kV per meter, and for impulse voltages 500 kV per meter is to be maintained. And for switching surges, the clearances is typically worked out from the following formula, that is the simplest formula, D is equal to 2V square, where D is in meters the distance and V is in million volts. So, in case the voltage level, as per the voltage level, this distance or the clearances are to be followed. The simplest equation. So, importance of the layout of high voltage laboratories, we were discussing about various aspects, the clearances and so on. So, it is also important to see that to provide an efficient testing facility, very important. So, laboratory arrangements could differ very much from a single equipment, it could be of a DC, AC and an impulse arrangements in different testing programs. So, each laboratory has to be designed individually considering the type of equipment which is to be tested, the available space in the laboratory, other accessories which could be needed for conducting the tests, and the storage space or the equipment housing space or any other accessories or pertaining to the test yard, the storage space required. So, proper planning has to be done. The grounding or earthing, very important, control gear and safety precautions are essential and require most careful consideration. So, without proper earthing and grounding and safety aspects, the high voltage laboratories have to be considered as a topmost priority for earthing and safety precautions. The control room which facilitates should be located and it should include a good overall view of the entire laboratory preferably, and the main access door which is entering the laboratory to the test area must accommodate the entire test equipment, the test object, have adequate interlocking arrangements, and there should be available a warning system particularly to ensure safety to the personnel who are involved in the testing activities at the high voltage laboratories. So, very important factors. So, this is the typical layout of the high voltage laboratory with a 1 million cascade transformer and a 3 million impulse generator. So, just to show that how the clearances of various equipments are to be considered. You can see that this 1, 2, 3 here, these are the cascade transformers, each of a particular rating of 350 kV. Say it is a 1 million source. The minimum clearances are indicated here, 1.7 and 2.5 meters are the minimum clearances which are essential to be kept away. Then you have a DC charging equipment, which is very important. So, DC charging equipment, and we have an impulse generator, we have, which is here, impulse current generator, and you have a impulse voltage generator 6 here, impulse current generator again, which is having a clearance of minimum clearances. These are very important. It gives the laboratory size of 40 meters by 20 meters, and all the clearances are mentioned, and each equipment has been provided necessary clearances. You have a spark gap arrangement which is to be used for testing, and the minimum clearances have to be maintained. Then the DC test setup. So, DC test setup, again it is kept at a corner with a clearance from not interfering with other equipments. You have a control room or a Faraday cage arrangement here in the 9. So, this again gives the dimensions of mentioned here. So, typically you have an impulse voltage generator, cascade transformer set of 3 units, you have impulse generator, impulse current generator, a DC set, and also the sphere gap arrangement. So, this typically gives the clearances of various equipments which are normally housed in a high voltage laboratory of 40 meters width by 25 meters or so and 20 meters. So, very important, and there could be higher voltage equipments which could be housed with higher clearances. So, some of the high voltage laboratories which have various sizes for power frequency impulse switching surges are available in several parts of the globe. Few examples are here. In France you have a size of laboratory size of 65 meters by 65 by 45 meters height, where the facilities like the power frequency you have a 2.25 million volt, current rating of 1 and amp, and impulse test facility of 7.2 million volts and energy 450 kilojoules, and switching surge facility of 6 million. Similarly, laboratories are available in Hydrocubic, Canada, Chesi, Italy, you have in USSR, you have in Australia, Japan, Sweden, UK, Brazil. These are the values of the sizes of the outdoor laboratories. These are the power frequency equipment with the current rating. You have an impulse test facility and a switching surge. All the details are given here. So, several laboratories across the globe have high voltage facilities for conducting research, for testing the equipment, and for certification purpose. Similarly, in the country, that was in abroad, in the India we also have several high voltage labs, both for research development and also for the industrial routine testing. The laboratories are available at Bharat Heavy Electrical Limited. They have a size of high voltage lab of 67 meters by 35 by 35 meters in height, and they have a power frequency equipment of 1.5 million with a current rating of 2 amps and impulse test facility of 4 million having a energy of 400 kilojoules and a switching surge facility of 2 megajoules. So, then Central Power Research Institute has a number of laboratories across the country. They have at Bhopal, they have at Hyderabad, Bangalore, and they have several labs. One of the lab at Bangalore is given as 50 meters by 40 by 35 is the high voltage lab, having a power frequency of around 2 million and a current rating of 2 amps and impulse of 2.4 million and 30 kilojoules energy and 1.5. These statistics could be of earlier values. Now there are equipment which have been housed and upgraded their existing earlier facilities. So, Indian Institute of Science, we have the facility high voltage lab of 37.5 meter length, 30 meters breadth and 20 meters height. We have a power frequency of 1.05 million volt having a 1 amp source and impulse test facility of 3 million with 50 kilojoules and a switching surge rating of 1.6 kV. So, similarly IIT Indian Institute of Madras has a high voltage laboratory, Engineering College Jabalpur, Anna University, Jadavpur University, JNTU Kakinada, Central Power Research Institute Hyderabad has also an outdoor facilities. So, these are few of the examples. There could be some more which have been established recently with the facilities for conducting and carrying out research activity and also for the developmental activity. So, we have tried to discuss about the importance of the planning of the high voltage laboratories for the testing of equipments. The important component being the grounding of impulse laboratory in the testing laboratory is very important. So, here an earthing or a ground system is an established stable reference potential, that is 0 potential, very important to be noted. 3 types of grounding systems are normally employed in the impulse testing laboratories. This could be ideal ground, the second could be the single point and the bus ground. These are the 3 different types of grounding which are normally employed. Of all these, the best ground is the ideal ground, which cannot be realized in practice, difficult, very difficult. The next preferred ground is a single point ground. This we will we will discuss how it looks, and third is the bus ground, which is least satisfactory. So, the ideal ground can be approximated by an equipotential plane realized by a finite conducting material, and the entire laboratory is covered by a sheet of copper metal which is welded into a single unit. But this is very costly and is used in few of the laboratories for few of the equipments to be tested, limited to some tests. So, a single point ground is commonly employed. In this, an earthing grid is installed within the laboratory floor, and connection from the grid is given to a single large sized copper conductor to a point identified as a common ground point. So, it is very important. The ground connections of various equipments and other components of the high voltage test circuits are normally connected to this common ground. So, this gives the information about the single point grounding and also the bus grounding. You can see all the equipments are connected to a single point earthing connection, where it could be the numbers which have been shown here could be impulse voltage generator, a spark gap or a spear gap, the position of the test object for impulse test, impulse current generator, position of the charging rectifier set. So, all are connected to a single point grounding here. Similarly, here it is shown, it is connected through a bus grounding system. So, GB is the ground bus what you see here, and G is the ground connection or a ground connection position at different location. So, all the equipments which again the impulse generator, spear gap, current generator, AC transformer set, DC, several of these things in a laboratory hall are connected by using the bus grounding or the ground connection position which is being shown here. So, importance of either going in for a single point grounding or a bus grounding is to see that the rise of potential should be brought down, and the equipments which are under test and also which are to be tested have to be properly grounded. Importance of electromagnetic shielding and earth return in high voltage laboratory is also essential, very important point. So, in any high voltage lab, a small, it could be a small laboratory, a medium or a large size laboratory should have some type of screening pertaining to the electrostatic and electromagnetic field interferences, which could be caused by the external sources. So, the screening is essential if partial discharge measurements are being made in the laboratory. So, here an attenuation of less than 40 or less than, much less than this value is needed for attenuation of electrical signals in the frequency range of 1 megahertz, while a still lower attenuation is needed for the electromagnetic signals. So, for large test laboratories, the attenuation levels due to interference are higher and arise mostly due to the imperfect screening. So, importance is to see that the entire laboratory is properly shielded and no interference is seen or observed during the testing of the equipment. So, several applicable standards are being suggested both internationally and national standards. So, some of the standards which have been shown here are the recommended standards for grounding of industrial commercial power systems. So, several standards are been given as a guide for safety in substations grounding, for earth resistance, for powering and grounding equipments, for industrial commercial applications, substation groundings, for checking the impedance and earth potential of the ground system. Several standards, both IEEE, IEC and SIGRES standards are available, have to be properly followed for the high voltage laboratories, and which have been recommended for good practice for the substations or high voltage laboratories. So, these are all several standards which have been available for our grounding system. And apart from the standards, it is important, if any grounding system is not routinely inspected or tested, so it is difficult to know if it is adequate or effective for the needs of the facilities which are to be tested. So, proper inspection, proper testing routinely has to be conducted for the grounding or earthing systems. So, that concludes the planning of the high voltage laboratories, and importance of the standards which have been suggested. So, thank you there.